Farmer's Guide Consultancy. In this publication, deficiencies. Nitrogen, N, deficiency. The chlorotic symptoms shown by this leaf resulted from nitrogen deficiency. A light red cast can also be seen on the veins and petioles. Under nitrogen deficiency, the older mature leaves gradually change from the normal characteristic green appearance to a much paler green. As the deficiency progresses, these older leaves become uniformly yellow, chlorotic. Leaves approach a yellowish-white color under extreme deficiency. The young leaves at the top of the plant maintain a green but paler color and tend to become smaller in size. Branching is reduced in nitrogen-deficient plants, resulting in short, spindly plants. The yellowing in nitrogen deficiency is uniform over the entire leaf, including the veins. In some plants, the underside of the leaves and/or the petioles and midribs develop traces of a reddish or purple color. In some plants, this coloration can be quite bright. As the deficiency progresses, the older leaves also show more of a tendency to wilt under mild water stress and become senescent much earlier than usual. Recovery of deficient plants to applied nitrogen is immediate, days, and spectacular. Deficiency. Deficient leaves show some necrotic spots. As a rule, phosphorus deficiency symptoms are not very distinct and thus difficult to identify. A major visual symptom is that the plants are dwarfed or stunted. Phosphorus-deficient plants develop very slowly in relation to other plants growing under similar environmental conditions but without phosphorus deficiency. Phosphorus-deficient plants are often mistaken for unstressed but much younger plants. Species such as tomato develop a distinct purpling of the stem, petiole and the undersides of the leaves. Under severe deficiency conditions, there is also a tendency for leaves to develop a blue-gray luster. In older leaves under very severe deficiency conditions, a brown netted veining of the leaves may develop. Potassium deficiency. Some of these leaves show marginal necrosis, tip burn, others at a more advanced deficiency status show necrosis in the interveinal spaces between the main veins along with interveinal chlorosis. This group of symptoms is very characteristic of K deficiency symptoms. Potassium deficiency is generally characterized by a marginal chlorosis progressing into a dry leathery tan scorch on recently matured leaves, even if potassium is given to the plants. Because potassium is very mobile within the plant, symptoms only develop on young leaves in the case of extreme deficiency. Potassium deficiency can be greatly alleviated in the presence of sodium, but the resulting sodium-rich plants are much more succulent than a high-potassium plant. Calcium-deficient leaves show necrosis around the base of the leaves. The very low mobility of calcium is a major factor determining the expression of calcium deficiency symptoms in plants. Classic symptoms of calcium deficiency include blossom end rot of tomato, which is generally related to poor translocation of calcium to the tissue rather than a low external supply of calcium. Very slow-growing plants with a deficient supply of calcium may retranslocate sufficient calcium from older leaves to maintain growth with only a marginal chlorosis of the leaves. Plants under chronic calcium deficiency have a much greater tendency to wilt than non-stressed plants. Magnesium deficiency. The Mg-deficient leaves show advanced interveinal chlorosis, with necrosis developing in the highly chlorotic tissue. In its advanced form, magnesium deficiency may superficially resemble potassium deficiency. In the case of magnesium deficiency, the symptoms generally start with mottled chlorotic areas developing in the interveinal tissue. The interveinal laminae tissue tends to expand proportionately more than the other leaf tissues, producing a raised puckered surface, with the top of the puckers progressively going from chlorotic to necrotic tissue. Sulfur deficiency. This leaf shows a general overall chlorosis while still retaining some green color. The veins and petioles show a very distinct reddish color. The visual symptoms of sulfur deficiency are very similar to the chlorosis found in nitrogen deficiency. However, in sulfur deficiency, the yellowing is much more uniform over the entire plant, including young leaves. The reddish color often found on the underside of the leaves and the petioles has a more pinkish tone and is much less vivid than that found in nitrogen deficiency. With advanced sulfur deficiency, brown lesions and/or necrotic spots often develop along the petiole, and the leaves tend to become more erect and often twisted and brittle. Nutritional deficiencies. MAGANESE deficiency. These leaves show a light interveinal chlorosis developed under a limited supply of Mn. The early stages of the chlorosis induced by manganese deficiency are somewhat similar to iron deficiency. They begin with a light chlorosis of the young leaves and netted veins of the mature leaves, especially when they are viewed through transmitted light. As the stress increases, the leaves take on a gray metallic sheen and develop dark freckled and necrotic areas along the veins. A purplish luster may also develop on the upper surface of the leaves. Molybdenum deficiency. These leaves show some mottled spotting along with some interveinal chlorosis. An early symptom for molybdenum deficiency is a general overall chlorosis, similar to the symptom for nitrogen deficiency but generally without the reddish coloration on the undersides of the leaves. This results from the requirement for molybdenum in the reduction of nitrate, which needs to be reduced prior to its assimilation by the plant. Thus, the initial symptoms of molybdenum deficiency are in fact those of nitrogen deficiency. However, molybdenum has other metabolic functions within the plant, and hence there are deficiency symptoms even when reduced nitrogen is available. At high concentrations, molybdenum has a very distinctive toxicity symptom in that the leaves turn a very brilliant orange. Zinc deficiency. This leaf shows an advanced case of interveinal necrosis. In the early stages of zinc deficiency, the younger leaves become yellow and pitting develops in the interveinal upper surfaces of the mature leaves. Guttation is also prevalent. As the deficiency progresses, these symptoms develop into an intense interveinal necrosis, but the main veins remain green, as in the symptoms of recovering iron deficiency. In many plants, especially trees, the leaves become very small and the internodes shorten, producing a rosette-like appearance. Boron deficiency. Boron deficient show a light general chlorosis. The tolerance of plants to boron varies greatly, to the extent that the boron concentrations necessary for the growth of plants having a high boron requirement may be toxic to plants sensitive to boron. Boron is poorly transported in the phloem of most plants. Copper deficiency. Copper deficient leaves are curled, and the petioles bend downward. Copper deficiency may be expressed as a light overall chlorosis along with the permanent loss of turgor in the young leaves. Recently matured leaves show netted, green veining with areas bleaching to a whitish gray. Some leaves develop sunken necrotic spots and have a tendency to bend downward. Trees under chronic copper deficiency develop a rosette form of growth. Leaves are small and chlorotic with spotty necrosis. Nutritional deficiencies. Copper deficiency. Copper deficient leaves are curled, and the petioles bend downward. Copper deficiency may be expressed as a light overall chlorosis along with the permanent loss of turgor in the young leaves. Recently matured leaves show netted, green veining with areas bleaching to a whitish gray. Some leaves develop sunken necrotic spots and have a tendency to bend downward. Trees under chronic copper deficiency develop a rosette form of growth. Leaves are small and chlorotic with spotty necrosis. Iron deficiency. Iron deficient leaves show strong chlorosis at the base of the leaves with some green netting. The most common symptom for iron deficiency starts out as an interveinal chlorosis of the youngest leaves, evolves into an overall chlorosis, and ends as a totally bleached leaf. The bleached areas often develop necrotic spots. Up until the time the leaves become almost completely white, they will recover upon application of iron. In the recovery phase, the veins are the first to recover as indicated by the bright green color. This distinct venial re-greening observed during iron recovery is probably the most recognizable symptom in all of classical plant nutrition. Because iron has a low mobility, iron deficiency symptoms appear first on the youngest leaves. Iron deficiency is strongly associated with calcareous soils and anaerobic conditions.